In this lesson, we're going to cover Big Idea 4, Standard 4, and our topic for today is VSEPR. So you do need your chemistry resource packet, and the page that we're going to use today looks like this. It says VSEPR Theory on the top. So first, let's talk about what VSEPR is. VSEPR stands for valence shell electron pair repulsion. So our electrons in that valence shell are outermost energy levels. Those electrons are going to repel. So why does this matter? What is VSEPR theory used for? It is used to predict the geometry, the molecular geometry, or the shape of molecules. VSEPR is used to predict the geometry or the shape of molecules. We know that electrons are negatively charged. Electrons have negative charges, and we know that like charges repel. So what happens is when these electrons are going to repel, it is going to push our molecule into different shapes. That repulsion pushes molecules into specific shapes. So this PhET simulation does a really nice job of showing our molecular geometry and how adding additional atoms is going to change the shape. So here we can see that the atoms attached to our central atom are 180 degrees apart. And if I try to move those atoms closer together, notice that they're going to repel. The repulsion is trying, or the shape is trying to minimize the repulsion. So these atoms are going to be as far away from each other as possible. They're going to adopt a shape that minimizes that repulsion. If I were to add another atom, notice that now they are each 120 degrees apart. Again, they are going to repel. That repulsion is going to push this molecule into a different shape. It is adopting a different shape to minimize the repulsion. So how do we figure out what shape it's going to form? So we'll go through the steps. Step 1 is to draw the Lewis structure. You have to have a correct Lewis structure in order to figure out your molecular geometry. Step number 2. Determine the number of atoms, not the number of bonds, the number of atoms attached to the central atom. Step 3. Determine the number of pairs of electrons. Not the number of electrons, the number of pairs of electrons. On the central atom. Lastly, Once we know how many atoms are attached to the central atom, and we know the number of pairs of electrons on the central atom, we can then determine the shape using the reference sheet. And again, this reference sheet is in your chemistry resource packet. First one. Let's do NH3. And we're going to go through all of our steps. So step 1, we have to draw the Lewis structure. Nitrogen is in group 5. It would have 5 valence electrons. I have 3 hydrogens to place. Hydrogen is in group 1. Hydrogen has 1 valence electron. Unpaired electrons are going to be shared, and we're going to form a bond. Step 2. Determine how many atoms are attached to the central atom. 1, 2, 3. Next step, determine the number of pairs of electrons. We have 1 pair. Now, lastly, we can determine the shape using the reference sheet. So here is my reference sheet. In the first column, it tells me how many atoms are attached to the central atom. And then the next column tells me how many pairs there are. So I'm looking for 3 atoms attached, 1 pair. So use your reference sheet, find 3 atoms attached, 1 pair. So 3 atoms attached, 1 electron pair, this is trigonal pyramidal. So that would be your answer. My VSEPR shape, or my molecular geometry, would be trigonal pyramidal. Alright, let's try another one. We'll go through all of our steps again. Let's do carbon tetrachloride. Carbon tetrachloride. That prefix tetra means 4. So step 1 is we need to draw the Lewis structure. Carbon goes in the middle. Carbon is in group 4, so carbon has 4 valence electrons. I have 4 chlorines to place around carbon. Chlorine is in group 7. So each chlorine has 7 valence electrons. Remember, we never want to touch our pairs of electrons, but if we have unpaired electrons, they can be shared and we can form bonds. So that is step 1. Step 1, draw your Lewis structure. Step 2, how many atoms are attached to the central atom? 1, 2, 3, 4. Step 3, determine how many pairs of electrons are on the central atom. Well, carbon is my central atom, it's in the middle. It doesn't have any pairs of electrons. All of its electrons are shared in bonds. So it has 0 lone pairs of electrons. So step 1, draw the Lewis structure. Step 2, figure out how many atoms are attached. Step 3, figure out how many pairs of electrons. Step 4, use your reference sheet to figure out our geometry. So 4 atoms attached, 0 lone pairs. My shape would be tetrahedral. Tetrahedral. So the hard thing about VSEPR is you really need to have a solid understanding of how to draw your Lewis structures. If your Lewis structure isn't drawn correctly, there is a good chance that you're not going to have the correct molecular geometry. Let's do 2 more. Let's try carbon dioxide. Step 1, draw your Lewis structure. Again, carbon is in group 4, so it has 4 valence electrons. Oxygen is in group 6, 6 valence electrons, 6 dots. Electrons that are unpaired can be shared. So I'm going to redraw this so we can see it a little bit better. So carbon shares 2 pairs of electrons with oxygen, so I have a double bond. And then on the right-hand side, again, carbon shares 2 pairs of electrons. So again, I have a double bond. So step 1 is to draw your Lewis structure. Step 2, look at the central atom. How many atoms are attached to carbon? 2. Remember, we're counting the atoms, not the bonds. 1 oxygen here, 1 oxygen here. Next, are there any lone pairs of electrons on carbon? No. All of carbon's electrons are part of shared pairs. So then last step is we can use our reference sheet. We're looking for 2 atoms attached with 0 lone pairs. 2 atoms attached, 0 lone pairs. My shape would be linear. Linear. Last one, let's do water. Water has the formula H2O. So step 1, draw the Lewis structure. Whichever atom you only have 1 of will go in the middle, and the hydrogens will surround it. Again, we never want to touch the pairs of electrons, but unpaired electrons can be shared and we can form some bonds. So step 1, we draw the Lewis structure. Step 2, look at the central atom. How many atoms are attached? We have 2 atoms attached. Step 3, how many pairs of electrons are on the central atom? Oxygen is the central atom, and it has 2 pairs of electrons. Step 4, use your reference sheet and figure out our molecular geometry. I'm looking for 2 atoms attached with 2 pairs of electrons. 2 atoms attached, 2 pairs of electrons. The shape would be bent. And then again, the reason this happens is we are trying to adopt a shape that is going to minimize repulsion. So what happens is those shared pairs of electrons are going to repel, and it is going to push those hydrogens down. So water really is in this bent configuration. If we were to look at a water molecule, these lone pairs are going to repel those hydrogens into this position. It will not look like it is linear.